Welcome everyone to another episode of West Explains Best. We're going to be talking about factoring today, which is section 8.5. So let's go ahead and jump right in. One of the first things you need to understand about factoring is it's essentially the opposite of foiling, of multiplying binomials. For example, if we multiplied x plus 3 times x plus 4, how do we do that? Well, if you guys check a look at the previous video, you'll see that we can distribute both the x to both terms in the second parentheses and 3 to both. And we get x squared plus 4x plus 3x plus 12. The final answer being x squared plus 7x plus 12. So we went from factored form, which is, let me find a good color, which is this, into standard form, which is that. Factoring, we're doing the exact opposite. We start in standard form and we move it into factored form. Factored form is a very useful form to have your equations and expressions in mathematics because it allows us to see some properties of x a little bit more easily than in standard form. So how do we go about it? Well, let's say we have something called like x squared plus 9x plus 20. Essentially, we have three terms here. We have the first term, we have the last term, and we have the middle term, or the second term. If you want to call it first, second, third, that's good too, but generally it's first, middle, and last. I mean, that's at least the people I know. Okay, now your goal is to have it like this, where you have two parentheses with binomials. Okay, so that's your goal. Now, we already know that the first term, okay, it's got to have, when we distribute, when we're following this process right here, and we're foiling, or loifing, or however you want to call it, when we're foiling, we know that x times x is going to give us x squared. Okay, so our first terms, x times x, will give us our first term. Let's write that, I'm going to write it in red. This will give us our first term. Term is spelled with an E, FYI. Okay, now let's jump. I'm going to skip to the last one. These are our last terms multiplied. So I put an F here because that's our first terms. This is our first terms being multiplied together. So x times x will give us our first term here. Okay, so that will give us, let me move this over and I'm going to write x squared next to it too. So that's our first term. Okay, now this number times our number, this is going to give us our last term. So it's kind of convenient. Our last terms multiplied together will give us our last term in this trinomial. This is a trinomial. Why, you might ask? I hope you guys understand. Tri means three, and there's three terms. Trinomial, triceratops, tricycle, you guys get it. So this is our last term. Now what is our last term? In this case, our last term is which number? 20. Now, let's just kind of break down what this means so far. So far, it means when we multiply the first terms times each other, we get x times x, that gives us x squared. Now we're saying, okay, some number times itself, or two numbers times themselves, whatever number these are, these do not have to be the same. These can be different numbers. When you multiply those two numbers, we get 20. So think about it for a second, okay, multiplying two numbers to get 20, that limits our possibilities, okay? Now, we have the outside and inside. We already did first times first, last times last. Now we have the inside and the outside terms still to go when we do our foiling. So what do we do with those? Well, when we do the first and outside, we end up with the x times some number and then the other x times some different number. Again, these numbers can be different numbers. Okay? But when you add them together, this is what gives you the middle term. This is the key to factoring. I'm going to change this red to orange. Might as well stay consistent. There. Now, what is our middle term? In this case, it is 9x. Okay? So our first terms times together would give us our first term. Our last terms times together would give us our last term. And then the sum That's what this is. That's a sum of the outside and inside terms will give us our middle term. Okay, now, like I said, we're going to start with this here because we know that we're going to limit our choices based on the factors of 20. We know that two numbers need to multiply together to give us 20. When we put in parentheses, okay, so we're going to get our parentheses here. This will be our end game here. Not the movie, but you guys get what I mean. But when we multiply our last times our last, okay, this one times this one, we need to get 20. That's our end game. Okay, now let's go back to here. So we're going to list factors of 20. What times what will give us 20? Well, we know that 20 times 1 will give us 20. We know that 5 times 4 will give us 20. And we know that 10 times 2 will give us 20. Are there any others that you can think of? Technically, we could say negative 20 times a negative 1 would give us 20. Sorry, this is a little choppy. Negative 5 times a negative 4 would give us 20. And a negative 10 times negative 2 would give us positive 20. So it's important to think about both the negative and the positive. And as you do this more, you're going to see patterns, and I'll give you some tips on what to look for. But I'm just going to give you a heads up. Because this middle term is positive, none of these are going to be negative. Okay? Because both this and this are positive, none of them are going to be negative. Okay? Besides the point, we listed it down to 3 choices. So if we wanted to, we could go, oh, I'm going to put X, I'm going to put X, I'm going to put 20, I'm going to put 1, I'm going to put plus, I'm going to put plus. And we could see if this works, and we could try it out. We could say, okay, X times X, X squared, so far so good. Then we do 20 times 1, that gives us positive 20. That's our last term, so far so good. Then we multiply our inside terms, 20x, and our outside terms, 1x. We get x squared after we simplify, plus 21x plus 20. Just a heads up, I am doing this incorrectly. I just want you to see this as an example. We got x squared plus 21x plus 20. That is not the same thing. Our goal is to go from this into 2 parenthesis form. But we have to make sure it matches, otherwise it's no good. So what we did right here with the 20 and the 1 was no good. 20 and 1 was not a match. Why? Well, a trick is, not a trick, but an algorithmic way of figuring this out is we look and see which of these factors of 20 have a sum of the middle term. Okay, after you multiply it by the first terms. Okay, so essentially the easiest thing to think of is which of these terms, which of these factors, which of these factors add up to 9? Is 20 plus 1 9? No. Is 10 plus 2 9? No. But 5 plus 4 is 9, so we're going to put 5 and 4. Now let me show you why this works. Let me move this up. Okay, so I'm going to FOIL here. I'm going to do first times first, x squared. I can go ahead and do outside, that's fine. 4x, then I'm going to do inside, 5x, and then last, 20. I can always combine those two, so I get x squared plus 9x plus 20. See how it matches, see how it matches what we got? X squared plus 9x plus 20, x squared plus 9x plus 20. So the formula for how we went about this was correct. We first looked for, okay, what are our factors of this last term? Okay, so step 1, factors of last term. Step 2, we are going to see which factors have sum of middle term. Okay? In step 3, we check our answer. Well, I mean, I suppose we should say we put into parentheses as binomials. And then I guess step 4 would be check your answer, check answer. Okay, so that's the process. Now, I know that sounds pretty confusing for some of you that are seeing this for the first time. The more you do it, the easier it gets. So I'm going to go ahead and I'm just going to do, I guess we can go ahead and do these 4 examples. That's not too bad. And if they're at all confusing, you can fast forward, no, not fast forward, you can rewind, and hopefully they become more clear if you see it repeatedly. So the first thing I always like to do is I like to put parentheses. And the reason why I put parentheses is because I notice we have 1, 2, 3 terms. And the reason why we go into 2 parentheses, 2 binomials, is none of these have a common factor. There's no greatest common factor among all 3. If there's no GCF, then you have to put it into something like this. Okay, so now what do we do? Well, we're going to look at our factors of 7. What are our factors of 7? Our factors of 7 are 7 and 1, and also -7 and -1. Those are only things you can multiply together to get 7. Here's the issue. Now we're looking at this. Which of these have a sum of positive 8? Well, clearly -7 and -1 do not have a sum of positive 8. So there's only one possibility. It's got to be 7 and 1. Does 7 plus 1 equal 8? Yes, it does. So we're going to put 7 here. We're going to put 1 here. And we're going to put x and x here. We look at our factors of the first term, and we put them in the first slot. We look at our factors of the last term, and we put them in the second slot, the last slot. And then we check to see if these factors add up to give us our middle term. Do they add up? The answer is yes. So we're good to go. We're going to put positive, positive, and there is our answer. It's not too bad, is it? It just requires practice. You got to do this over and over again, okay? Let's do another one. Step 1. Well, actually, this is not what I listed as a step, but it's important. I like to put my parentheses down because I notice there's no greatest common factor here between all 3 terms. So I'm going to put my 2 parentheses. Now I'm going to look at factors of the last term. Here's something that's a little different now. The term is -5. So now it can't be +1 and +5. Those are no good because we have to get to a -5. So we could have a -5 and +1. We could have a +5 and a -1. And that's it. Those are the only 2 possibilities that multiply together to get -5. Which of these has a sum of +4? Which of these has a sum of +4? Clearly, it's not the first one. It's the second one. So what we're going to do is we're going to put these in as 5 and -1 because those are our factors of -5. Our factors of the first term are x and x. And then we're just going to add the plus here and we're good to go. So really, I can move this negative over and it becomes minus. Minus and negatives are the same thing, okay? Your elementary school teacher lied to you. There's only positive and negative numbers and then you combine them. There's no like subtracting. That's a weird way to think of it, I know, but believe me, it's like makes a lot more sense. -1 and -1 are the same thing. So that's our final answer. Our final answer is x minus 1 times x plus 5. Now, I've said check answer, but I didn't check answer last time. Let's go ahead and do that. I'm going to multiply x times x. I get x squared. X times 5, 5x. -1 times x, -1x. -1 times 5, -5. So you can see that we got x squared and we got -5. Those were the easy ones. It's the middle term that's the toughest. So we get x squared, combined like terms, +4x minus 5. That's the same thing we got earlier. That's how you know that we did this correctly. Okay, we got 2 more to go, and I don't want to waste too much more of your time. I've already wasted enough. So the first thing we're going to do, now I'm going to go about this a little differently. We can put our first terms first. So we know x times x will give us x squared. Usually this is the easier one. Now there are scenarios where it gets a little bit more complicated, but for now, x times x gives us x squared. That's pretty easy. Now we need to think of factors of -16. This one's going to be a little bit tougher. There's a lot more possibilities. So now we have 16, -1. -16, +1. We have 8, -2. We have -8, +2. We have 4, -4. And I believe that's it. That's all there is. Now we're going to look at each one of these, and the bigger the number, the harder it is, and we're going to see which of these has a sum of negative 6. So does 16 plus negative 1 equal negative 6? No. Does negative 16 plus 1 equal negative 6? No. Does 8 plus a negative 2 equal negative 6? No, it equals positive 6. And when you see that you get a positive 6 instead of a negative 6, you know you're close. You at least have the right factors, but you don't have the right signs in front. So we just change the signs. We make it negative 8 and positive 2, and we are good to go. We have our answer. So we have negative 8, positive 2. Again, it's important to check your answer. Practice what I preach here. X squared plus 2x minus 8x minus 16. Combine like terms, I get x squared minus 6x minus 16. I get the same thing. We're good to go. Last one. Put my parentheses. There's no greatest common factor between all three terms. I'm going to put my first term first. What is my first term? My factors of my first term are x. Now I'm going to go for my last term. What are my factors of positive 10? Okay, I have 5 and 2. I have negative 5, negative 2. I have 10 and 1. I have negative 10 and negative 1. Now, here's a giveaway. If you see that this is positive, the last term is positive, you know the signs need to match, right? Obviously, we can't have a negative 5 times a positive 2 to give us a positive 10. So they need to match. So we're going to look at the middle term to get an indication of what the sign should be. 5 and 2, positive 5 and positive 2 would not give us 7, so we know it has to be negative. There's our answer. So we have a negative 2 and a negative 5. X minus 5, x minus 2. That's going to be our answer. I'm going to check it real quick. X squared minus 2x minus 5x plus 10. X squared minus 7x plus 10. There you go. This was a whirlwind of a lesson, I know. I hope this is helpful. At least consider this. These are all for when there's not a greatest common factor among three terms. Until next time, you guys be good, be kind, be true, be nice, and be honest. I'll see you later.